Hi guys, here's part one of the fraction quiz study guide. And I'll end up doing 3 videos because 3 pages, if I did it all at once, I think it'd take a really long time. So hopefully you checked out the answer key and did this already. This is more of a check on your learning or help if you're stuck. So first part here, model these fractions or mixed numbers, draw a picture. So you model 3/4. You want to first set up an object. We've said pies or boxes are always the best. In the denominator, if you remember a while back, we said the denominator was most important. So I need to split this thing up into fourths first. And there are a lot of different ways to do it, all vertical or whatever, but I'll first split it up into that many sections, and I'll say 3 of those is how many I need to shade. I always like the diagonal version. And so there you are, something as simple as that, 3 out of 4. 3 2/3, a little bit trickier at first, but I want to focus first on the fraction and then the denominator. So what I want to do is just come over and set up one object that's only 2/3. So first split it up into thirds and then shade in 2 of those sections. And so the fraction part is done. I just need to have 3 holes. Well, I want to make the holes all the exact same as that shape because I have 3 of those is the idea. And this is really for some people when they see this and they can't convert it to an improper fraction. This would help a lot. Draw it and mimic what you're doing here before. Okay, so they're all the exact same shape. But if you have all of these 3, then you would shade all those in. Okay, and what I mean by helping with the improper fraction is, let's say I could do the drawing but didn't know how to do the our little trick to do this. I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11/3. So that's, anyways, that's that one for now. You'll see our problems escalate from kind of easy concept to more complicated. And this is big help for finding equivalent fractions. Like say you were trying to find an equivalent fraction for 1/2. You even knew that it was supposed to be 8ths, but you didn't know how many it was supposed to be. As long as you have a shape that matches that completely and shade in sort of the same picture, right? Like if this is a pizza cut in half, this is the same amount of pizza, it's just now cut into more pieces. So I really ended up shading in 4 out of how many total? 8. And that's that. That's all we meant by that one. This one I got to be careful with it, and I want to kind of identify, all right, I shaded 2 out of 3. So how many is that here? Well, I have 1, 2, 3, 4, 5, 6. Okay, if I just did a look at the drawing, I would kind of know right about there. Not halfway, a little bit more. And I've shaded in a total of 4, 8, and 12 out of how many? Well, I have 6 by 3. That's going to be 18. Okay. And if you notice, we'll see this in a second, but equivalent fractions, whatever's happening on the top times 6 has to happen on the bottom times 6. Simplify a fraction to its simplest form. So there's a lot of ways to do this. I personally prefer to just look for my primes and just kind of cut it down each time. And my primes are 2, 3, 5. That's what most things are going to end up being. But don't forget about 7s and 11s. I mean, you could take it even further to 13 and 17, but for now, these ones are going to be okay. And we'll look and I'll say, well, these are both divisible by 2. So I'm going to divide them both by 2. Divide it by 2 on the top, divide it by 2 on the bottom. I'm going to get to 6 10s, right? My quick check was that they were both even, so I knew they were both 2s. If they were both 3s, I would divide them both by 3s. And don't forget that 3s check is, this number here. Is it divisible by 3? No, because 5 plus 6 is 11, and that's not a 3. But is this number here divisible by 3? Call it 54. I want to make sure I write down a good one. 54, regardless of that little line, sorry. If I do 5 plus 4, that gives me 9. So that's a quick check. Since that's a 3, that this would work. But our problem over here, they're both even still. So divide the top and bottom by 2 again. 6 divided by 2 is 3. 10 divided by 2 is 5. And one thing for me, I can't go any lower than this. 3 and 5, I can't divide them both by the same number anymore. But if I have 2 primes, that's a good time to kind of think I'm probably finished. So that's as simple as we can make 12/20ths. When I look at 14 over 35, I'll do those divisibility checks, and I'll say, all right, are they both 2s? No, this one's not. Are they both 3s? No, that's not a 3. Are they both 5s? This is, but that's not. Now, are they both 7s? This is where knowing your math facts is huge. They are both 7s. So if I divide the top and bottom by 7, 14 divided by 7 is going to give me 2. 35 divided by 7 is going to give me 5. And now once again I'm at 2 primes, and that's probably as low as I can go. So 2/5 is that answer. Okay, you got to divide the top and the bottom by the same thing when we're trying to keep the same value. Identify the lowest common denominator. Now, a while back we had done lowest common multiple, specifically for this purpose, to say what's the smallest number they can both multiply to make. And to do that, I would take the two denominators, 3 and 5, and I would just start skip counting by those numbers and see what's the smallest thing that they can be. So first I'll just do 3, maybe like 5 times. So I'll say 3, 6, 9, 12, 15. A lot of times my other number will be within that, and maybe I should have skip counted by the larger one first. I would skip count by whichever one you're least comfortable with. That way it might jump out to you. The other multiple would jump out to you quicker. But if I skip count by 5s a little bit, that's not going to work. That's not tied. That's not common. But 15, there it is. So 15 is the first number that they share. So why do we do this? Hopefully you realize, like, if I'm going to add these or do anything with them, I can't do it right now. I can't add a 3rd and 4/5. I'd have to turn them both into 15ths. And that'll come up. That skill is going to come up a little bit later. 6 and 9 is all I'm going to look at here. I don't care about the top yet for this style problem. So as I line them up, and let me try that. I'll do the bigger number first 5 times. So 9, that's not a 6. 18, well, I think that is a 6. So actually, let me just come over and do my 6s. 6, 12, 18. Sure enough, there it was. Didn't have to go that far for that. So some people just look at that and say, oh, 6 times 9, that's 54. Well, that's not the lowest common denominator. And you want to try to work with the smallest one, because then the rest of the fractions are easy to add, and follow-on steps are easier too. So 18 is our lowest common denominator for number 8. Big time skill here. So I need to find an equivalent fraction for 1/4. And maybe I've already identified a problem like this. Okay, I got to get to 16. So I have to first, what I always do is say, draw an arrow, put these guys next to each other and say, how do I get from 4 to 16? And it's got to be multiplying or dividing. So 4 times what gives me 16? Well, that's times 4. So whatever I do in the top, or whatever I did in the bottom, has to be done in the top. So 1 times 4, very easy one. 4 16ths is the same as 1/4. So 4. I'll kind of go quicker here. How do I get from 5 to 25? Times 5. So I got to do the same to the top. Times 5. 3 times 5 is 15. Switched it up here to have the denominator be the empty one, but it really is the same thing. How do I get from 3 to 21? 3, 6, 9, 12, 15, 18, 21. Times 7. So do the same to the bottom, times 7, and I get 28. 21 over 28 is the same as 3/4. So here's that connection to the top ones. I need to turn these into improper fractions. That's the only way to do some of our other math here, is to use improper fractions. We kept showing this shortcut where we'd say circle these two, put a times sign, and put a plus. Okay, and I'm going to say, what's 4 times 3? That's 12. And then don't forget this plus 2. That gives me 14. So my new fraction is going to be 14 over. I'm thinking, oh no, what do I do? What's the denominator? Just go back to the original. What was that denominator? It was 3. So 14/3. And the way that works is just to say, if these 4 are all wholes, a whole can be 2 over 2, 3 over 3, or 5 over 5, whatever. In this case, since the other ones are thirds, I should assume these are thirds. So I would say, all right, what is this? 3/3 plus 3/3 plus 3/3 plus 3/3. Well, multiplication is a shortcut for stuff like this. Instead of doing adding 4 times with 3, I just say 3 times 4. That's where that shortcut really stems from. That would give me 12 over 3 again. Adding the 2 over 3, I'd have 14/3. 11 and 1/5, well, circle these guys, times, plus. 11 times 5, 55. Plus 1 more, 56. Put it over 5. Leave it there, because if you put it back in like the proper form, well, I'd just be going back there, and that's kind of makes this problem sort of moot. And then final two on this page, turn these back into mixed numbers. I gotta remember that this sign means division. And so when I'm stuck, I'll set up a long division problem, you know, or just think how many times can 3 go into 11 without going over. But this is more set up to see that. So 3 can't go into 1. Can 3 go into 11? Yeah, 3 can go into 11 3 times without going over. 3, 6, 9. 12 would be too many, you know, so 4 can't work. So 3 times 3 is 9. I subtract that, 11 minus 9, and I have 2 left over. Now, this is the old days. I would say 3R2, 3 remainder 2. But I need a mixed number, and that's not including a remainder. That's, you know, whole number and fraction. So this, I have 2 left over. So really, that's like 2. Because remember, we said that was the value. 2 is my numerator. And then what do I put it over? I come back and I say, what was this, or what was I dividing by? It's 3. So I should have 3 and 2 thirds. Here, a little bit of a larger number, but don't be freaked out. Rearrange it, you know, if you need to. Some of you guys are really good. You just know, oh, 40 it must be at 45 would be 9, but this is 42, so it's going to be 8. 5 cannot go into 4. 5 goes into 42 8 times perfectly. If you skip count by 5s, we got, I don't know if these fingers will fit out here, but 5, 10, 15, 20, 25, 30, 35, 40, so that's 8 fingers. If I have another one that's 45, that's too many, so it's 8. 8 got me to 40, so 5 can go into 42 8 times, because 5 times 8 was 40. And I'll subtract it. I have 2 left over. I'll bring that up, and then I've got my 2 as sort of left over, and that's still being divided by 5. So my final answer for this one, 8 2/5. Okay, that's it for page 1, guys. Take a look at page 2 if you need it, and page 3 if you need it later.